And welcome back to the very last AP Chemistry 2022 FRQ video. And this is going to be FRQ number 7. And yeah, I guess the next time I'll make one of these is for May of next year, 2023, which is so crazy. Yeah, let's go ahead and begin. You can access these FRQ questions in the link in the description box down below, or you can copy and paste the link shown in the video right now into your search bar. As always, this is not affiliated with the AP College Board in any way, shape, or form. This is just a video answering the possible solutions to the AP Chemistry 2022 exam. And without further ado, let's get started. Question 7a asks us for the hybridization of the carbon in the oxalate ion. So in order to know this, you need to know how many electron domains are around each carbon. So here are the carbon elements they're talking about right here. And we could really use either one. It doesn't really matter because they both have the same number of electron domains. So there are going to be 3 of them because there are 3 bonds around each carbon atom. So if there are 3 bonds, that corresponds with trigonal planar, but it's not really asking for like the shape. That's just extra information. It's actually asking for the hybridization, which will be sp2. You can count the exponents to see if it matches the electron domain number. So the S has an exponent of 1, and then the P has an exponent of 2. So 2 plus 1 is 3, and we do have 3 electron domains. So that's kind of like a quick shortcut. Next up for part 1 of 7b, we have silver oxalate, and we have to write the expression for Ksp. Ksp shows the solid and what it will break into when dissolving in water. Because this is partially soluble in water, it will start off with the solid silver oxalate, and it will then be in equilibrium with the silver ion concentration and the oxalate ion, and they will both be aqueous. Now, and that's just because they are dissolved in water. Now, we also need to balance this equation, so I'm going to place a 2 in front of the silver, which will make this balanced. Now, using this, let's find the Ksb expression, which will be the silver in brackets squared because of the coefficient of 2 in the front, and then the oxalate ion in brackets as well, and that will be the final answer for the Ksb expression. Now let's move on to the second part, which is 7b, and it asks us to find the molar solubility of the silver oxalate in water. So let's bring back the equation of what happens to the solid in water, and we're going to be doing an ice table to find out what needs to be replaced. Let's start by placing our I, C, and E, which is our acronym, and that actually stands for initial, concentration, and equilibrium. So our initial for the silver oxalate solid is just going to be dashes because we don't include solid in our ice tables, of course. And then for both concentrations, it's just going to be a 0 because we don't have anything. And now we need to find out the change. The change is always positive on the product side, so it's going to be a positive 2x for the silver, and because of the 2, it's going to be a 2x. And then for the oxalate ion, it is just a positive x because the coefficient is 1. Now the equilibrium will be, we're going to do 0 plus 2x, which is 2x, and then 0 plus x is just x. Now we're going to take the 2x and we're going to replace it with the silver, and we're going to take the x and replace that with the oxalate. Now let's go ahead and clean up everything and bring back our equation for reference. And let's also bring back our Ksb expression. And the Ksb value, which was given in the problem earlier, is going to be 5.4 times 10 to the negative 12. And then to replace the silver and the oxalate, we already found that, which was the 2x and the x. And so now it will be 2x squared and then just the x. So if you multiply the 2x twice, you get 4x squared, and then you're going to multiply it by another x, and that will be 4x cubed. Solve for x, and then you get your value as 1.1 times 10 to the negative 4 as your answer. And for the third and last part of 7b, we have to find the balanced net-ionic equation between silver oxalate and perchloric acid. And remember that if you memorized your strong acids before the test, perchloric is definitely a strong acid, which means that it will 100% ionize. So let's begin with our silver oxalate, which is aqueous, and let's add that to the perchloric acid, which is also aqueous. And that's going to yield some unknown product, which we'll have to find ourselves. And in order to find those unknown products, we must cross down charges. So if we break apart the silver oxalate, it will be the Ag plus and the oxalate 2 minus. And that's because the 2 next to the silver goes up as a charge for the oxalate. Now for the perchloric acid, it's going to be the H plus and a ClO4 minus. Now we switch and cross back down charges. So the Ag plus and the ClO4 minus will go together, and then the oxalate and the H plus will come together. Now taking the silver and the ClO4 minus, it will come together to be the silver, the ClO4 like so, and then the H plus and the oxalate will come together like that. Now let's replace our new products to the product side, and I'm going to get rid of our work to clean up our space. And for the phases, they're both going to be aqueous because they're both going to be dissolving in water. Now we need to balance our equation. It looks like there are 2 moles of the silver on the reactant side, so we need to balance that by placing 2 moles of silver on the product side. And we need to do the same for the hydrogen on the reactant side because there are 2 moles of that on the product side. Now that we're done balancing all of that, let's start by writing the complete ionic equation first. We can start by breaking apart the silver and the oxalate, so it'll be the 2 Ag plus, and we're going to add that to the oxalate ion, and then the 2H plus, adding that to the 2 ClO4 minus, and remember that the 2 does distribute to both, and that will then yield 2 Ag plus, 2 ClO4 minus, and just the oxalic acid, which is weak, so it will not break apart, and we'll just let it be. Now remember that this is the complete ionic equation, but in the problem it is asking us for the net ionic equation. So in order to find that, we can cross out the spectator ions. Spectator ions are ions that appear on both sides of the reaction because they do not actually exist in the reaction. They're just there and we need to cancel them out. I can cross off the 2 Ag plus because they appear on both sides. And I can also cross off the 2 ClO4 minus because, again, they do appear on both sides. And after that, there are no more. So now whatever is left will be the net ionic equation, which is going to be all of this. And I'll transfer everything, and you get this equation as the final ionic equation. Remember to keep the phases as well. And when you dissolve the silver oxalate with the perchloric acid, this is like the equation that you get. Also, just note that if you are increasing the solubility, you are increasing the amount of products. And so notice how our product in the net ionic equation is our oxalate ion, which is the C2O4 from the equation above. And C2O4 also happens to be a product from the first equation above, which is something we want to maximize or increase its solubility. So this definitely makes sense in this context. And here are my unofficial score predictions to pass the test. And that brings us to the end of the video. So thank you so much for watching. Make sure to give this video a like, comment if you have any questions about the video, and make sure to subscribe if you learned something new. If you took the AP language test and want to know the answers, you can check out my video on the left, and if you want to know the answers to the 6th FRQ in this series, then check out the video on the right. And thank you so much. I'll see you guys next time.